Hi, we are Team 17. I am Srinivasan, she's Minerva, and we are here to summarize our week 1.
The objective of week 1 was to understand which technologies work best for us and to eliminate the ones that didn't.
And I took up the task of using Kinect and Unity 3D. There were so many challenges, and the solution was to introduce a new SDK called ZDK. Harshita took up the task of using Kinect and Java with 3D, and the only challenge that she faced was there was no enough support for J4K library.
I worked with the physics engine for the Kinect. It was used to simulate physical systems on the Kinect. Nivedita worked on 2D games for Kinect. We were inclined towards 2D because we were planning to use Greenfoot.
And Soumya took up the task of checking out the existing Greenfoot Kinect projects, and it was the feasible and practical way to go.
Hi, this is Harshita and this is Nivedita. We are here to summarize the task in week 2. The team extended their task from week 1 into week 2. Soumya worked on Greenfoot and she tried to integrate Kinect with it, so that she also tried to collaborate Greenfoot on one machine to work with another machines. And Srini tried to research on Zigfoot ZDK, and it required knowledge of open source projects such as NI and NITE, and the ZDK was also available only for the trial version.
And after looking into several ideas for our game, we finalized on doing a car game, and I did a prototype in Greenfoot. And Minerva looked into sample games in Blender and also looked into OS Skeleton, which is middleware which converts Kinect data, Kinect Skeleton into OSC data and sends it back to Blender.
I worked on finding out the support available for Java 4K library versus C#. So by the end of week 2, we had decided to continue building the game on C# and Unity.
I am Nivedita and I will be explaining the 2D car game prototype that we did in Greenfoot. So here we have our world, which consists of the racetrack, and then we have several actors, the main classes being the car and the truck. There are 4 different types of car and 2 different types of trucks. We have considered the green car to be our player. And so the obstacles are made to move continuously using the set location entry here. So once the obstacles reach the end of the world, they are reintroduced into the world using these set location entries. And when the up arrow is pressed, the objects are made to accelerate using this set location entry. So the green car can move to the right and left using the move method in actor. So when the left arrow is pressed, it moves to the left, and when the right arrow is pressed, it moves to the right. So let's see the working of the game now. So you can see that the objects keep moving and reappearing in the world. And to move the green car, we can use the left and right arrows. And when the up arrow is pressed, you can see that the other objects speed up. So this was the prototype that we were working on, Greenfoot.
Week 3, after looking into our 2D prototype game, we thought that it would be more interesting to do it in 3D, and so we started looking into Unity. I looked into games being designed using JavaScript in Unity, and Minerva looked into Sandbox game in Unity, which is an interactive game.
I was exploring the different games available in Leap Motion, and so that it will help us in laying down the requirements for the game. Srini worked on identifying and researching on the gestures available for the Leap Motion product, and Soumya worked on the app submission and the policies regarding Leap Motion.
Hi, I'm Soumya and I'll be explaining the basic prototype of the car game which we're developing in Unity 3D. So this is our game scene. We have used 5 game objects: main camera, directional light, car, forest ground, and the road. Main camera captures the whole scene of the game. Directional light provides the lighting for our game. Without this directional light, the scenes would be very dark. Car being the main object of our game, as the whole game revolves around our car. Next is the forest ground, which is the terrain on which we have many mountains surrounding the whole area and dense forest trees, as you can see. And we have also kept in the middle of the forest a road. The road is very smooth so that the car can zoom off at high speeds. To the car, we have put an audio clip, so whenever the car moves, the acceleration sound is heard. And also I have attached a car control JavaScript which controls the movement of the car. So here I've used 2 variables, speed and rotation speed. Rotation speed controls the wheel rotations, and speed is the acceleration speed of the car. The vertical and the horizontal axes gets the position of the car as and when it moves. I'll now show a basic demo of our game. To the main camera, we have used Unity's target field of view script, to which we have provided our target as the car. So wherever the car moves, the main camera follows behind it, so that the whole play of the game is captured. Further on in our game, we are planning to put obstacles in our forest so that it will be challenging for the player of the game to drive the car through those obstacles and reach the end destination. So this was our prototype of the game which we're developing in Unity 3D. Thank you.
Let's look into week 4 tasks. Harshita worked on integrating Unity game engine with Leap Motion SDK. She faced some compiler issues and she's still working on it. Nivedita worked with Leap.js in Leap Motion. I worked on exploring Unity game engine to develop a simple prototype of a simple car game. Whenever worked on moving game objects like rotation of a gumball and adding colors and gradients to the moving game objects. Srini worked on exploring Unity's texture, compression and reflection mapping. So these were the week 4 tasks.